Okay, Honors for Math. This is your review session video. I will fair warn you, it's kind of a long video. There are several problems. I tried to do anywhere from... So this is a rather long video, so if I were you, I would probably stop the video after each problem, do the video, and then start the video again, and I will actually go over the problem. If you want to fast forward to certain problems, that's totally up to you. But I tried to do a couple of each type of problem you might actually see on the exam. Okay, here we go. Good luck. So here's our first problem. It's an equation to solve. So you might want to pause the video right now, do the problem, and then come back and watch how I do it. Alright, so the first thing we're going to do is do the distributive property. So you should get negative 6x plus 12 minus 9x equals negative 4 minus 6x plus 12. I'm going to combine like terms on the same side, so this is going to give me negative 15x plus 12 equals, over here, negative 4 and 12 gives me 8 minus 6x. I'm going to move my variables to one side, and we get 12 equals 8 plus 9x. Subtract 8 from both sides. We get 4 equals 9x. Divide both sides by 9. And I got a final answer of 4/9. Okay, number 2. So we have an inequality and it says to solve and graph it. So the first thing I'm going to do is I'm going to eliminate the fractions. I forgot to tell you to pause the video and work it out and then start it again. I'm going to multiply both sides by 6, and we get 4x plus 3 is greater than or equal to negative 36. I'm going to subtract 3 from both sides, and we get 4x is greater than or equal to negative 39. Divide both sides by 4, and I don't have to flip the sign because I'm not multiplying or dividing both sides by a negative. So we get a final answer of x is greater than or equal to negative 39 over 4. So to graph this one, we would have to put negative 39 over 4 and 39 over 4. Whoops. And we would want to make sure that we put the negative 39 over 4. We'd want to say that it falls in between negative 9 and 10. So negative 9, negative 10. I just didn't have room enough to write underneath the graph. It's going to be a closed circle and shade to the right. Okay? Problem number 3. Problem number 3 is a compound inequality. So pause the video and solve it and graph it. Now this compound inequality is automatically an and because it doesn't say or. So I'm going to split it into 2 inequalities, and I'm going to make sure I write the word in between and. And as I split it in 2, I'm also going to go ahead and do the distributive property. So on the left side, I have negative 12x plus 18 is greater than 4x minus 8. And then if I split the other half, it would be 4x minus 8 is greater than or equal to negative 2x plus 1. So there's my 2 inequalities that I have to solve. On the left one, I'm going to subtract 4x from both sides. And you get negative 16x plus 18 is greater than negative 8. Subtract 18. And we get negative 16x is greater than negative 26. Divide both sides by negative 16. And you have to flip the sign because we divided both sides by negative. So that's x is less than 13 over 8. 2 negatives make a positive. And on the right side, if I add 2x to both sides, we get 6x minus 8 is greater than or equal to 1. Add 8 to both sides, and you get 6x is greater than or equal to 9. Divide both sides by 6, and x is greater than or equal to 3/2. When I go to graph this problem, we have 13/8 and we have 3/2. Well, 13/8 is 1 5/8, which is more than 1 1/2. So I know that's going to go farther right than 3/2. 3/2 would go more here because it's exactly 1 1/2. So x is less than 13/8. That would be an open circle, shade to the left. And x is greater than or equal to 3/2. That would be a closed circle, shade to the right. Now, it's not all solutions because it's not an or. If it would have been an or, it would have been all solutions. But since it's an and, it's only where the two colors, the white and the yellow, overlap. So it would be in between 3/2 and 13/8. We'd put a closed circle on 3/2. We'd put an open circle on 3/8, and it'd be in between those two. So that's your solution set. Okay, next problem is another compound inequality. All right, so this one is an or, so go ahead, solve and graph it, pause the video, and then come back and watch how I solve it. Okay, so on the left side, we're going to subtract 2 from both sides, and we get negative 3/4 x is less than negative 14. Multiply both sides by 4 over negative 3, because that's the reciprocal. I'm going to flip my sign because I multiplied both sides by negative, and you get x is greater than, well, 2 negatives make a positive, and then 14 times 4 is 16 over 3. So x is greater than 16/3 is the first answer. Or, on the right one, I'm going to multiply both sides by 4. And what happens here is my 4's cancel out, and you get negative 3 times the quantity 2x minus 1 is less than 40. I'm going to do the distributive property. Negative 6x plus 3 is less than 40. Subtract 3 from both sides, and we get negative 6x is less than 37. Divide by negative 6. And we get x is greater than, because you have to flip the sign, 37 over negative 6. So I go to graph it. 37 over negative 6 is obviously going to go on the left side, and 16/3 is going to go on the right side. It's greater than 16/3, and it's greater than 37 over negative 6. And an or is wherever anything is shaded. So therefore, since my graph is everything to the right of negative 37/6, my final answer would just be negative 37/6, open circle, shade to the right. Next problem is our favorite order of operations. Okay, so here's your problem. Pause the video, work it out, and then come back and watch me work it out. Okay, so I'm going to do what's inside parentheses first, and I'm going to try to do some of the exponents in the first step. So we have negative 3 in parentheses negative 7 minus 12 divided by 3 times negative 5 minus 3 to the third is 27 minus 9 squared is 81. Okay, in the next step, I'm going to do that other exponent. Now I have negative 3 times negative 7, and I'm also going to do 12 divided by 3. Remember, when you've got multiplication and division in the same problem, you always go left to right. So we have to do this division before the multiplication. So minus 12 divided by 3 is 4 times negative 5 minus 27 minus 81. Okay, I'm going to do the negative 3 times negative 7, which is 21, minus, I can go ahead and do this multiplication. 4 times negative 5 is negative 20, minus 27, minus 81. Now, addition, subtraction, you got to do one problem at a time, left to right. So 21 minus negative 20 is 41. You can't do anything else. 41 minus 27 is 14. Minus 81 is negative 67 as your final answer. Okay, next problem, I'm going to do another order of operations, but this time it's going to be one of the big fraction problems because I feel like we always need to practice those a little bit too. Okay, so here's your problem. Go ahead and try it. Pause the video and come back when you're ready. Okay, I'm going to try to do a step on the bottom and step on the top at the same time. So I'm going to do all my exponents on top first. So that negative 4 squared, notice the negative 4 is not in parentheses. So that's 4 squared, and then I still have a negative to put on it. So on top, I have negative 16 plus 3 times negative 2 times negative 3 minus 2 to the 4th is 16. On the bottom, I don't have any exponents, so I'm going to do that first multiplication problem. So negative 6 minus 9 plus negative 12 times negative 2. Back on top, I'm going to do the first multiplication problem, not negative 16 plus 3. I should not be doing addition yet. So this is negative 16 plus negative 6 times negative 3 minus 16. On the bottom, I'm going to do that last multiplication problem, negative 6 minus 9 plus 24. Back on top, I'm going to do that last multiplication problem in the middle. So negative 16 plus 18 minus 16. On the bottom, negative 6 minus 9 is negative 15 plus 24. On the top, negative 16 plus 18 is 2 minus 16 over negative 15 plus 24 is 9. Back on top one more time, negative 14 over 9 is my final answer. Okay, the next problem, we're going to start doing some of the slope and graphing problems. So my next one is just a problem where we're going to find the slope given 2 points. But I put some fractions in to make this one a little bit harder. So go ahead and try this problem and then come back when you're ready to watch how I do it. Okay, so on top we know we're going to do 5/6 minus 3/4. And on the bottom we're going to do negative 1/2 minus negative 2/3. Common denominator on top is 12, so we have 10/12 minus 9/12. On the bottom, the common denominator is 6, so we get negative 3/6 minus negative 4/6. On top, 10/12 minus 9/12 is 1/12. On the bottom, negative 3/6 minus negative 4/6 would give me 1/6. Now, this really says 1/12 divided by 1/6. So therefore, we have 1/12, and we multiply by the reciprocal, 6 over 1. 6 goes into 12 twice, so we have a final answer of 1/2. Okay, the next one is going to be where we are going to do some graphing. And we're going to do the first one, we're going to do a graphing in slope-intercept form. This is what one of the problems would look like on the exam. There would be an equation, there would be a graph given to you, and then there would be a blank for the slope and y-intercept. And let's remember, we always write every point, the y-intercept is going to be in an ordered pair. So pause the problem, try it, and then come back and watch me do it. So first thing I'm going to do is I'm going to do the distributive property because I've got to get this problem in the form of slope-intercept. So now I'm going to move all my y's to one side and everything else to the other. So if I take positive y and I move it to the left, that's going to give me y, because 2y minus y is y. If I add 2x to the right side, I've got negative 3x plus 2x is just negative x. And then that minus 2 is going to stay on the right. So my slope is negative 1 over 1. My y-intercept is 0, negative 2. So when I go to graph it, I'm going to go down to negative 2 and I'm going to put a point. And then my slope is negative 1 over 1, so I'm going to go down 1, right 1. I could do that again if I wanted to. Or I could go up 1, left 1. And then I'm going to draw my line. And I'd be done. Now generally you guys ask, how many points do you have to have? I would say you only have to have 2 or 3. I just always go in both directions at least once just to make sure I get them to line up and make sure I'm doing it correctly. Okay, the next one is still going to be a graphing, but this time instead of slope-intercept form, we're going to graph in standard form. Now remember, standard form is ax plus by equals c, and this is where on the test there will be a blank for x-intercept and y-intercept, and of course you got to make sure you write those in ordered pairs. So here's your problem you're going to graph, so go ahead and pause the video, try it, come back and watch how I do it. Okay, for the x-intercept, if you recall, we let y equal 0. So for the x-intercept, we let y equal 0. So if I plug in 0 into that problem, that means the 3/4 y is going to go away, and we end up with negative 1/2 x equals negative 12. So I'm going to multiply both sides by 2 over negative 1. And I'm going to get an x-intercept of positive 24. Oops, I kind of made a bad problem, but it'll work out. So my x-intercept is 24, 0. And then my y-intercept, you let x equal 0. So that means the negative 1/2 x would be gone. And I ended up with 3/4 y equals negative 12. Multiply both sides by 4 over 3. And when we do that, we get y is, 3 goes into 12 4 times, we get negative 16. So my y-intercept is 0, negative 16. Now, you won't have to do this on the exam, but what I'm going to do is I'm going to pretend that each one of these little lines on my graph is, well, I'd say 2, but I don't even think we're going to have room for that. So let's say that each one is 4. So that would be 4, 8, 12, 16, 20, 24. You won't have to worry about them being so big on the test. 0, negative 16, that'd be negative 4, negative 8, negative 12, negative 16. So when I graph my line, there's what you get. Remember, each one of those lines was actually representing 4. Okay, the next problems are going to be where we actually write the equation of the line, given whatever information I give you. And the first problem that we're going to do is we're going to write it in slope-intercept form. So that needs to be reminded maybe for some of us that means we need it in the form of y equals mx plus b and before we're done. So here's the problem that we have. We've been given a point and a slope. So I'm going to plug in 2, 3 equals y minus 3 over x plus 4. I'm ready to cross multiply and I'm going to slope-intercept form, so I'm going to go the direction of y first. So I get 3y minus 9 equals 2x plus 8. I need to add 9 to both sides. and we get 3y equals 2x plus 17. Solve for y, so divide everything by 3, and you get y is 2/3 x plus 17/3. That'd be your answer on that problem. Okay, so here's our next problem. This is one of the problems where we're talking about perpendicular, x-intercepts, all those fun things. So this one we're going to write the equation in slope-intercept form that is perpendicular to y equals -3 halves x plus 2 and has the same x-intercept as -2x minus 4y equals 12. Alright, so how would we do this? Well, the equation y equals -3x plus 2, we know the slope of that line is already easy for us. That's -3 halves. So I want perpendicular to that, so that's opposite reciprocal, so that's going to be 2/3. Then we want to find the x-intercept of this line. Well, -2x minus 4y equals 12. To find the x-intercept, we let y equal 0. So that gives me -2x equals 12. So my x-intercept is -6. So there's my point. So I've got a slope, I've got a point. Now I'm ready to actually do the work. So we have 2/3 equals y minus 0 over x plus 6. The answer needs to be in slope-intercept form, so I'm going to cross multiply the y direction first. So 3 times y is 3y. 3 times 0 is 0, so I don't need to write that. And then 2 times x, and then 2 times 6. Slope-intercept form is y equals mx plus b, so all I have left to do is divide everything by 3. And I get a final answer of y equals 2/3 x plus 4. We always want to make sure we simplify our fractions wherever we can. Okay, next problem. So this one we want the answer in standard form, which we may need to be reminded is ax plus by equals c. And this line passes through the 2 points -3, 8, and 4, -2. Alright, here's how you do it. So first of all, we need to find the slope of the line. -2 minus 8, 4 minus -3. That gives me -10 over 7. Now I can use either point in the next step, so I'm going to do -10/7 equals y minus 8, x plus 3. Now because I'm going to standard form, I'm going to cross multiply and go the x way first. So when I do that, I get -10x minus 30 equals 7y minus 56. Standard form, I need to subtract 7y from both sides, and I need to add 30 to both sides. You can do that in 2 separate steps. You don't have to do it in one step if that's not comfortable for you. We get -10x minus 7y equals -26. Now, if you would stop there, that would not be standard form, because remember, standard form cannot have any fractions, cannot have any decimals, and a can't be negative. So right now, a is negative, so I need to divide the whole problem by -1. So my final answer is 10x plus 7y equals 26. That's what I get when I divide everything by -1. Okay, this problem, we're going to write the equation of the line in standard form that is parallel to -1/2 x plus 3 is y, and it passes through the origin. So pause the video, try it, and then come back and watch me do it. Okay, so we want it to be parallel to this line. Well, that's already in slope-intercept form, which means the slope of this line is -1/2. So if the slope of that line is -1/2, the line parallel to it is exactly the same, so it's also -1/2. And the line passes through the origin. Well, at this point, you should know the origin is 0, 0. So we have -1/2 equals y minus 0 over x minus 0. All right, so we're going to standard form, which again is ax plus by equals c. So I want to cross and go the x direction first. Negative 1 times x is negative 1x. Negative 1 times 0 is 0, so I don't need to write that. 2 times y is 2y. 2 times 0 is 0, I don't need to write that. Now to get this in the form of standard form, I've got to subtract 2y to both sides. And I get the answer of negative 1x minus 2y equals 0. But again, that is not in standard form because a is negative. So I'm going to divide everything by 1, or not 1, negative 1. And we get the answer of x plus 2y equals 0. So I'm reviewing the Pythagorean theorem here, and what I did on this picture was reminded you the Pythagorean theorem is a squared plus b squared equals c squared. It only works for right triangles, and you have to know that a and b are always the two sides that make up the legs of the right angle, and then c has to be the other side, which is opposite the right angle. So I forgot to start the video and I've already been working this through. So if you notice, I'll just go back and review what I did. So what happened was I gave you a triangle and you were missing the left side of it. And I gave you the 5 inches and the 14 inches. I knew that the 5 and the question mark had to be your legs of the triangle. And the 14 had to be the hypotenuse. So therefore I have a squared plus b squared equals c squared. So 5 squared plus b squared equals 14 squared. So that gives me 25 plus b squared equals 186. So I'm in the process of solving this. And you get b squared equals 171. Now that's not our answer. We have to take the square root of both sides. And the directions on the test will be find the answer to the nearest tenth. So of course for the test you're going to want to make sure you actually have a calculator. When I take the square root of 171, I believe it came up to be 13.1 to the nearest tenth, and I believe on the test I will ask you to the nearest tenth. So there's how you do a Pythagorean theorem problem. The other thing that can happen with the Pythagorean theorem is I may give you 3 measurements and you have to figure out whether or not they would make a right triangle. So for example, if I just gave you 3 random numbers, let's say 7 feet, 10 feet, and 4 feet. You're supposed to use the Pythagorean theorem and determine would these 3 measurements make a right triangle or not. Well, if I give you 3 measurements, you got to know which one's A, B, and C. Well, the only one I know for sure is I know the longest side has to be C. The other 2, they can go in A or B, it doesn't really matter. So I know 10 has to be my C. So 7 and 4 have to be A and B. So 7 squared plus 4 squared. So I work the problem out and I get 49 plus 16 equals 100. 49 plus 16 is, let's see, 65. And because 65 doesn't equal 100, then this is no, it's not a right triangle. If the 2 numbers would come out equal, then I would be able to say, yes, this is a right triangle. Okay, the last 2 topics we need to review is everyone's favorite, weighted averages and uniform motion. So we're going to start with a weighted average problem. So here's the problem. Go ahead and try it, set up your chart, solve the problem, then come back and I'll do it for you so you can compare yours to mine. Alright, so in my chart, I know that I'm going to be talking about pencils and erasers. Sorry, that top word says pencils. All right, and what do I know about them? Well, I know the pencils are 10 cents each, so I'm going to put 10 cents. And I know the erasers are 15 cents each. I'm going to put 15 cents. And then the next one talks about, let's talk about the quantity. We sold 17 more pencils than erasers. So if I put X for erasers, we're going to put X plus 17 for pencils. Okay, and the only other thing I know about this problem is I know how much total money was collected from erasers and pencils. So I know that that's going to be after my equal sign in my problem. So that's the equals 2345. So the next thing I need to do is I need to take 0.1 x plus 0.1 times 17 is going to be $1.70. And on the erasers, we have 0.15x. So my equation is 0.10x plus $1.70 plus 0.15x. So if I combine my like terms, I have 0.25x. And if I subtract $1.70 from both sides, I get $21.75. And if I divide both sides by 0.25, I come up with x is 87 erasers. So 87 erasers were sold. And then how many pencils? Well, it's 17 more than that. So x plus 17 would be 104 pencils. So this is erasers, this is pencils. So hopefully that problem worked out for you. Okay, problem number 19, or slide 19. I'm not even sure what problem we are on at this point. Let's do another weighted averages. Okay, so try this problem and then come back and see how we should do it. So we have Molly has 48 milliliters of solution that is 25% acid. How much of a 10% acid solution should she add to obtain a solution that is 15% acid? Okay, so our chart's going to be, we have a 25% solution, acid. We're adding a 10% solution acid, and we're trying to get a mix that is 15%. Okay, so let's see here. How much of the 25% do we have? We have 48 milliliters. How much of the 10% do we have? Well, we don't know, so that's going to be my x. And then my mixture of 15%, we're going to have the 48 that we had originally plus whatever we add, so we have 48 plus x. Okay, so we're ready to multiply our percentages, and remember, you need to change your percents to decimals. So it's 0.25 times 48, and it's 0.10x, and it's 0.15 times 48 plus x. All right, so 0.25 times 48 is going to be 12, plus 0.10x equals 7.2 plus 0.15x. Okay, so I'm going to subtract 0.10x from both sides, and I get 0.05x equals, if I take 12 minus 7.2, that's going to be 4.8. If I take 4.8, divided by 0.05, I get x is 96. So we're going to add 96 milliliters of our 10% to our 25% to get our mix of 15% that we want. Okay? All right, uniform motion is next. Okay, so here's your problem. Try it and then come back and I will go over it with you. So we have, suppose John and Gina leave at the same time traveling in the same direction. Gina drives at a rate of 85 kilometers per hour and John at 70. How long until they are 90 kilometers apart? Okay, so our chart would have John and Gina. And we know we need a column for distance, rate, and time. John is traveling at 70 miles per hour, and Gina is traveling at 85. They leave at the same time, so I know my x is going to be my time. And then, of course, what do we do with those two columns? We multiply them. So we get 70x, we get 85x. And it says how long until they are 90 kilometers apart. So if they're going in opposite direction, or no, they're going in the same direction. So we've got Gina going this way, and we've got John going this way. John is going slower than Gina, so actually the arrow would go this way, sorry. So we want to know, when are they 90 kilometers apart? So this is one that we actually subtract. We're going to subtract John's distance from Gina's distance because he's going slower. So we would have Gina 85x and John is 70x. And what's this equal? We want to know when they are 90 miles apart. So 85 minus 70 is 15. X equals 90. And this gives me an answer of 6. So the question is, did I get the answer I want? Well, the problem says how long. So 6, and that is time. So it takes them 6 hours to be 90 kilometers apart. Okay, one more, uniform motion. Alright, so here's your last problem for our review session. So go ahead and try it, and then come back and I'll go over it. Alright, so in this problem we've got Mr. Anderson and Mr. Basham each driving home from a Chicago choir meeting. Mr. A traveled east at 100 kilometers per hour and Mr. B traveled west at 80 kilometers per hour. In how many hours will they be 1,000 kilometers apart? Alright, so first of all, we've got Mr. A and we've got Mr. Basham. And we have distance, rate, and time. Mr. Anderson was going 100 kilometers per hour. Mr. Basham was going 80. They leave at the same time, so we know that's going to be each of these x. So Mr. Anderson's distance is 100x and Mr. Basham's distance is 80x. Okay, now let's think about what's really happening here. We've got Mr. Anderson and Mr. Basham both starting out in Chicago. Okay, Mr. Anderson's going to go east and Mr. Basham's going to go west, so they're going in opposite directions. We want to know, when is their total distance 1,000 kilometers? So we'd have to add their distances. So we would have 100x plus 80x equals 1,000 kilometers. Whereas in the last problem, they were going in the same direction, so we subtracted them. So we have 180x equals 1,000. Divide both sides by 180. And we get the answer is 5.5 repeating hours. But we're not going to use that. We're going to change that to hours and minutes. So we know this is 5 hours. And if you take 0.5 repeating times 60, it turns into 33 1/3 minutes. Or 33 minutes, 20 seconds. And that's how long it'll take them to be 1,000 kilometers apart. Okay, hopefully this review session has helped, and I will see you tomorrow.